Well, I hope you enjoyed the first disappearing act of the entire conference. I love how big the crowd is. I love how big the screen is when it actually works. I could actually fit BEM selectors in here, so that's pretty great. Animations bring user interfaces to life. Native application developers know this intuitively, and that's why they pack every single app that you interact with full of animations that not only delight the user, but they also make the app as easy and intuitive to use. So the question is, how could we bring those types of animations over to, well, the web? Now, I don't really like talking about myself, so instead, I'm going to talk about 4 people who really influenced me early in my career. And that's Manuela, Rachel Neighbors, Leah Veru, and Val Head. When I was first starting web development, I'm sure you've all seen the site, but there's an awesome site called Code Drops, where there were these amazing demos. And the ones that really struck me out the most were the ones that didn't look like your typical website. They were the ones that filled up the screen, they transformed smoothly from one state to another. And even though these, believe it or not, were about 4 or 5 years old, I think this is from 2014. To me, and to many others, it seems really ahead of our time. Even now, you see these animations, and you're like, why don't, most other websites and web applications have these types of animations? And so it really influenced me to, I have a backup, don't worry, to make animations such as this. This was one of my first code pens I've ever done. I saw a dribble and I wanted to recreate it. And at the time, I wasn't really good at JavaScript. So as you could see, there's no JavaScript there. And I tried to do it completely in CSS. And so I did this with a few other concepts, even ones that really should use JavaScript, like this one right here. But when I made these, I started discovering little techniques and little strategies, especially working just in CSS. And I started to think you could make these awesome effects, either without using JavaScript or with using the most minimal JavaScript necessary. Now, I know this talk is, named Beyond the Illusions. However, I'm not going to be talking about Houdini. That's going to come later. And, for all intents and purposes, Houdini's greatest magic tricks right now are escaping from CSS constraints, which is why it's called Houdini, and sort of disappearing from browsers, at least for the next 5 years. I mean, we'll see if that changes. Now, CSS is truly magical. I mean, think about it. You can make things float in midair, right? You can make things disappear. In fact, you could even do incredible things like vertically centering things. So CSS is magic, and I want you to stop calling, just weird CSS quirks and, things like hacks. Instead, let's call them illusions, because CSS is completely visual, so in essence, they are illusions. Now today, we're going to be talking about and revealing the secrets behind animating position without animating top, right, bottom, left. And some of you may know why we want to avoid those properties. Also, animating size without directly animating width or height. Animating gradients without animating color, which causes repaints. Animating on curves without using motion or offset paths, which aren't fully supported in all browsers. And also, animating border radius without fear. So our goal is 60 frames per second. I mean, you've heard this a lot, right? You've heard that you should avoid layouts and use transform and opacity whenever you can. Avoid repaints, which is where you could use opacity. But the thing is that you should mostly avoid being dogmatic. Just because you're told that you should avoid these things doesn't mean that you have to 100% avoid them. The most important thing that you could do is measure. Open up your dev tools and make sure that even if you are animating border radius or you have to animate color somewhere, Instead of doing a whole ton of CSS just to achieve that effect without touching repaint or layout, just measure, because chances are you might get 60 frames per second anyway. And so this is sort of the thinking that that went behind like making all of my animations and all of my demos, was I didn't really measure immediately from the start, but it was more incremental, where if I noticed something was slow, that's when I measured. So one of the main concepts that we're going to be talking today about is called the flip technique. And this is the type of animation that we want to achieve. Imagine a gallery view or a music app like this, something very Google material, where you have one element and it smoothly goes from point A to point B. But the difference is you don't know where those point A and point B places are, so you sort of have to find a way to animate it smoothly without touching height or width or position. And the flip technique was coined by Paul Lewis of Google, and it stands for first, last, invert, play. This is sort of a mnemonic for remembering the steps involved in doing this. So first, you get the initial position of the element. In this case, it is you use get bounding client rect, and actually this is wrong. You could take the element, the box element, and then there's a method on it called get bounding client rect. And in this, you get the position, which is top, left, and you also get the size, which is the width and height. This is going to be your favorite method for doing these sorts of layout animations because it gives you absolutely everything necessary to perform your animation. And then you perform your change. So let's say we go from view A to view B. That's when you get the bounding box of the last element. In this case, it's going to be bigger, and it's shifted up a little. Here's where the math comes in, and I promise it's elementary math, nothing crazy. But we take the deltas, which is the difference between the first and last value of both the position and the width and height. And using those values, we could take the second element over here, and we could squish it back down to where the first element was. So we create the illusion that the second element didn't move yet, and then we just animate everything to 0. So using transform, first we scale it to make it down to the first size, and then we translate it to make it to the original position. And then we animate everything to 0, and it bounces right to the second position. Now, you could do this like relative to the document, but sometimes you're going to have more than one element animating at the same time, and those elements might be nested. So for instance, let's say that I have an element in the box right here, and the parent box is moving, but so is the child element. What we want to do in order to prevent any glitches is we have to do a little bit of math, and this is what I like to call relative flipping. So what we would do is we would measure the parent's delta and the child delta, and then we would calculate the deltas relative to each other. So instead of calculating how this orange box moved from there to there, we first move the parent and then calculate relative to the parent how it moved from here to there. And so I like to call this technique like the flip-flop technique. First, last, invert play, first, last, outer play, so that you could observe the outer delta as well as the inner delta. But we're in Australia, so I'm going to call it the thong technique. Transform hierarchies of nested groups. It's shorter, easier to remember. All right, sad face. So here's sort of what we're going to be working with today. And these types of flip animations can be exhibited anywhere. And now that you know this and now that you know about the flip technique, you're going to start seeing them everywhere. So here's one animation that I made where I'm literally just changing the layout of the house. And instead of animating width and height, I'm actually animating transform and adjusting the elements based on that. And also, here's another one which is a little bit more dynamic. And this is sort of doing the same thing, where I'm using these flip animations to animate from one layout to the next. Now, to get to these, we have to go through a few CSS patterns. The first one is predictable layouts. Now, this is something that most of you will know. And it's actually amazing how many times I see projects that don't have like box sizing border box. It's more expected to maybe not have everything positioned relative. Honestly, this is one of my sins. Do not do this. I do this because I am lazy. So you will see in all of my copens, this is probably the most controversial thing you'll see in this entire conference, is this position relative everywhere, Don't do it. But it does give me predictable layout because I know that my child is always going to be positioned relative to the parent. So I know stacking context, blah, blah, blah. Also, smooth easings. This cubic Bezier thing, I always see the most random numbers in there. It does not have to be that complicated. I only use 0.5 and 1, and you could get a variety of exit easings from that, and they just work fine. So doing it this way, it actually makes it easier to visualize the cubic Bezier curve, as two dots where it's either 0.5 or it's 1, and then you could just sort of visualize that curve. I also use layered grids. Now, Brenda's going to be talking later about CSS grids today, so using grid is pretty much the best life hack for CSS that I've found so far, because you could take some layer, which is absolutely positioned, and you could stack the grids on top of each other, and then animate them independently, so you don't have to deal with the layouts fighting with each other. Also, background elements. This also might be a bit controversial, but you could use a separate div or a pseudo-element as a background element. The reason why I like to use a separate element is because I could actually add a box shadow to it, and that way we could animate opacity instead of animating height. And so that's the point over here. There was a really great article by Tobias Allen, if I'm pronouncing that correct, where he found that if you, instead of animating the box shadow property, you animated opacity on box shadow, you get a really similar effect at a much less performance cost. Also, something that is very important, and I've given talks about this before. I'm not going to talk too much about this because it would take the entire time, and I've already used 25 minutes wrestling with my computer. But it's finite state machines. That's representing your app in one state at a time. So all you need to know about how I use state machines in CSS is I have this data attribute called data state. And using that data attribute, I can make sure that there's only one attribute, or one state at a time, and we can't have multiple states. So let's get started with a few tricks. The first one is right over here, border radius. So I'm actually animating paint here, but the trick is we want to animate the border radius in a way that we don't get this effect right here. You see how the border radius jumps when we're scaling up the element? Now, the quick solution to this is to animate height and width. We want to completely avoid that. So instead, let's make it smooth. Just like that. And believe it or not, this only animates paint, and we're avoiding animating layout, which gives us a considerable performance boost. So the way we do that is first identifying the problem here is that when we scale the element and we squish it, we see that there's a bit of overlap between the last border radius and the first one. So what we could do instead is animate border radius. And there's a little bit of math here, but essentially, instead of letting this border radius be, we're going to stretch it a bit based on how much the width and height's changed. And so that's going to give us this effect. For instance, this element, it grew twice as wide and 1.5 times as tall. And so we could use those measurements in the border radius in order to stretch it to make up for how much it was squished. And then we get a nice smooth border radius animation. So next one, right over here. So you'll sort of see the secret to this really quick over there. But it's getting these smooth animation curves without having to use offset path or motion path or even any JavaScript like that. So these curved motion paths can be done using inverse rotations. This looks a little bit crazy, like your geometry homework or something like that. So I'm going to sort of make this easier to understand. The trick is that we're moving the transform origin, and we're rotating on the transform origin. So if you could visualize that, imagine this orange rectangle moving along this circle. And so by doing that, we could animate it to any point we want by both moving it that way and then translating it back to its next position. And so that's one way to do these motion curve animations. All right, more sad faces. So here's the next one. Expansion and collapse. This is not my pen. This is a pen by a friend, Shaw. And so what's happening over here is that we're expanding each of these panels to full width. And it's this really nice effect, no JavaScript involved. Normally, we would see something like this and say, we probably have to use clip path, or we have to animate width and height, or something like that. However, if you really, really, really want to animate width and height, then there is a way to do it. And that's called CSS containment. What containment is, it was originally in Chrome. It's in a few more browsers right now, but we could tell the browser that even though we're going to be changing the width and height of something, that the only thing that's going to be affected is that element. And so if we say contain layout, we tell the browser ignore any other possible changes. So it's in most browsers except IE&Edge. It's in Firefox under a green flag. IE&Edge probably have a white flag because they gave up on it. But there's also another technique. It's scaling and inverse scaling. This is an interesting technique because it was actually talked about by Paul Lewis and other people on the Google team. And so what's happening over here, you probably missed that, is that the parent is expanding while the child, since it's being expanded too much, it's collapsing at the same time. Now, this requires a lot of JavaScript if you want to do anything besides a linear easing, and you can't exactly animate to 0 because you can't divide 1 by 0 in CSS or JavaScript. I would hate to see what that would be like. There's also sliding layers, and this one requires a parent layer, but if you do overflow hidden on the parent layer, and then you move the child layer just to the right position, you could get that expanding effect just by animating them back to 0. And that was the technique that we were using in the pen that I showed you. There's also clip path animations. This one does trigger repaint, so again, you could use contain paint, or you could measure, and you could see, is this going to really affect my performance that much? So I actually have been working on a library for a long time called Flipping, just because that's a really fun name for a library. And flipping is meant to bring flip animations and the technique to the wider community and to make it a lot easier to make these animations. So to give you an idea of what it's like, you would add a data flip key to one element, and you would have the same data flip key on another element. So you could imagine that this view might be disappearing, and then this view might be appearing. Using flipping, we tell it, just via the flip technique, we say, first read, the first position, and then do something that changes the layout, such as, selecting a photo, and then you do flipping.flip, which is really fun to type out. But what that will do is, using an adapter, it will automatically animate your layouts from one position to the next. And so it does that by selecting the currently visible element and then just animating to it by calculating the deltas for you. So you don't have to do all that manual work automatically. And just to give you an idea of what this was like, I previously made an article where I had this sample gallery app, and I had no animations on it whatsoever. I added those data flip keys to the right places, and let's search for, what's a safe search? Melbourne, Australia. And then you see that every single element with those keys animates, exactly to, their position. So if we had this, I didn't know you guys had polar bears, but anyway, so using the data flip key, it will keep track of the positions of each one of those visible elements. And so, for example, over here, these are two completely different elements. The only thing they have in common is that data flip key. And so it knows that whenever you go from one to the other, it will just animate that for you. Here's another demo I made earlier where I added the data flip key to each letter just to see what happened. And you get this really, really cool effect where the letters animate, right into place. And then this morning, I was up at 4 because 4 o'clock is like 1 p.m. my time, and I'm still on my time, which is a bad idea. I shouldn't have done that. But I created this animation, which also uses flip. Let's say I wanted to edit my week. Get rid of these. And now I have a nice, long weekend. And so the animation of that Sunday card is done using the flip library. And it's animating both, we have the background element that's stretching, and we have this text element that also has a data flip key on it. So whenever it changes, it knows to calculate the delta and move smoothly from one position to the next. And so I just released, about an hour ago, version 1 of flipping, and so you could download it now, and you can play around with it. There's 2, almost 3 adapters right now. First is flipping. That's a very small version of the library where whenever something changes, it just gives you all this data. This is everything you could possibly want to create these animations. Flipping.web uses the web animation API, which works in both Firefox and Chrome. If you're using Safari, hopefully they get the web animations API working soon. And pretty soon, I'm going to be releasing flipping.css.js, which uses CSS variables in order to control your animations. And so I'm going to leave you with one of my favorite quotes from one of the people who influenced me the most when I was starting early on, Rachel Neighbors, where, "But there is power in animation, the power to create experiences that go beyond mere linked documents," it's HTML, "the power to immerse users in an illusion of life," because animation brings user interfaces to life. So thank you very much, CSS Comp. Here's a bunch of resources for you.